Hi, welcome everyone. My name is Rohit Sanjay, and I'll be speaking about unit testing in Python. Yep. So that's me, and I'm a final year engineering undergraduate at MIT Manipal in Karnataka, and I'm also the author and maintainer of an open source library called Testbook, which is a unit testing library for Jupyter notebooks, and it's under the Interact organization. I'm also an incoming software engineering intern at Goldman Sachs, Bengaluru. You can find my blog at rohitsanjay.com. All right, let's move on. So, I want to start off this talk with this uh, quote by Boris Bezer in his book called Software Testing Techniques. So, the quote goes like, more than the act of testing, the act of designing tests is one of the best bug preventers known. So the fact that you are thinking of writing tests or when you are designing the test itself, that is the phase where you encounter a lot of the bugs and you can fix them. So that's the power of unit testing. Moving on, this is the agenda for this talk. So I'll just talk very briefly about introduction to about unit testing in general, and then I'll talk about writing unit tests mostly. So I'll compare unit test and pytest. Then I'll speak a lot about mocking, and I'll also cover using context managers in your Python tests. And I'll also cover some of the features of pytest, like fixtures and parameterizations in tests. So introduction to unit testing. So unit testing in two sentences. A unit test is a test that checks that a single component operates in the right way. That's it. So you're testing a single unit. Um, there are other kinds of testing like integration testing and user acceptance testing. So these are all different kinds of testing. But one of the types of testing is called unit testing, which tests single components or single units. A unit test helps you to isolate what is broken in your application and fix it faster. So let's say there is something broken in one single component. You can only fix that, and then you can move on. So it helps to write unit tests that way. So that's it. Moving on. Unit test versus pytest. So unit test is the standard Python library for unit testing. It comes along with your Python distribution. You don't need to install anything for that. You just do import unit tests and boom, it's there. Whereas pytest is a third-party library which has gained a lot of traction over the years, and right now it is probably the most used testing library for in the Python space. And in fact, I think even the official documentation recommends using pytest. So just to show you a comparison, so unit test looks like this, where you have a class. So it's written in the JUnit style of testing. So you have a class called test string methods, and then you have the test functions written as methods of that class. So you have test upper, and then you have to I have to put a base class of unit test dot test case. So then you get all these assert equal, assert true, assert false, and then you can assert raises. All right, and then you run the test by just doing unit test dot main. So pretty simple. Whereas PyTest, it's, I would say, even simpler, where you don't even need to write a class for it. So that's not a mandate. You can, but you don't need to. And you instead use normal Python statements to assert. So you just call the Python assert on functions, and then you use equal to equal to. So it's pretty, I would say, more readable than the left, which is based off of unit test, right? And so unit test, the issue is that too much boilerplate code is needed. So you need to write a lot of code before you're actually writing your assert statements, which are also not actually proper assert statements. They are something like self.assert, assert raises, assert true. So you need to remember those statements. So, and when you look at the code at one glance, it might be hard to understand what exactly the code is trying to test. And this is exactly what I just said. So it makes the code's intent hard to understand. Also, there's camel case naming. If you've worked with Python for a while, you know that Python has, mostly snake case naming, which is underscore something underscore something else. So camel case is usually something borrowed from Java. So why I would say pytest is the better option is that it provides detailed info on failing assert statements. So if a statement, so if you're comparing two strings and some few characters are not matching, it will show you which characters are not matching. So it's nice. It's nice that way. And it also has auto discovery of test modules. You can it has a modular fixtures. So I'll talk about fixtures in the future, but in the coming slides. But fixtures are basically a way of reducing repetitive code by putting it in a common place. So if you have a resource that is shared across multiple tests, you would want to write a fixture for it and use it in all those tests. Also, you can do tests parameterization, where you can write, if you find yourself writing like copy pasting assert statements, if you find yourself copy pasting assert statements, then you can probably parameterize it, write one assert statement and pass in a list. So I'll speak about parameterization as well in the coming slides. And it can also run unit tests, test suites. So it's like a wrapper around unit tests. So you don't need to use one or the other, you can use both. And it also has a rich plugin architecture. So one of the major plugins that are used is called pytest cov for test coverage, which basically reports how many of your code statements have been hit and how many are not. So you can write tests to hit to cover all the lines of code in your source code. So also pytest looks better when the tests are running. So this is how unit test looks. Doesn't look too great because it's pretty bland. It doesn't tell you which tests have run, etc. Whereas with pytest you can make it. I mean, it looks a little better with colors and stuff. So that's good. All right. So now I'll talk about mocking. So mocking, it's when you simulate the look and feel of real world objects. Okay, so I have an example here. So if you look at this orange component, and if you think of it as a function or a class or something, it's interacting with these other components. Okay, it's interacting with four other components in this case, and you can also think of those other components as other function calls, as functions or as classes. So when you want to write a test for for one component, uh, you might get too overwhelmed with the interactions that it has with the other components. So in a sense, you would not be writing test for just that one component. You would be writing test for all the components that it's interacting with, and it can go on, right? Because that blue component is interacting with three more other components. So you need to mock out those interactions so that you're only testing that one component. So that's what mocking provides, and it's a unit testing principle. So the mock library is available as a sub package under unit test, which is also it's a standard library in Python. And the main API is called mock, which is a class. So you instantiate mock and then you get a mock object. So mock object is really flexible. You can play around with it uh, very well. So for example, I have a certain code here. So you just import the mock class, you create a mock object, m equal to mock parentheses, and then I can assign whatever I want to it. I can say m.foo equal to 42, and then if I ask it what's m.foo, it'll tell me it's 42. And if I ask it some attribute that I haven't assigned, m.bar, it will say, okay, it won't raise an attribute error or something. It will just say, okay, here's another mock object for your dot bar attribute. So it can keep going. I can keep going m dot bar one dot bar two dot bar three, call it a bunch of times, raise it to the power of 100. It will still return a mock object to me. So there's another one called patch. Patch it acts as a function decorator, a class decorator, and it can also act as a context manager. So a patch, what it does is, by the definition of patch, it patches out a particular function or a class with a mock object. So it basically replaces it. So to explain patch, I have an example here. So let's consider a class, a file called foo.py, which has a class called foo, capital Fo, and I have another file called bar.py, which imports this foo class and creates. And let's assume that this bar.py, right, it has some functions that use this foo class. Okay, so it has a lot of functions that use this foo class. So to write the tests for these functions in bar.py, I'll have to patch bar.foo, and then I can assert that it was called in the right way or something. I've just written here, for example, that dot return value equal to 42, but I can assert some things with this mock object called mock foo, right? But if you observe here, I've done bar.foo. So it's coming from the file, the module bar.py, and it's not coming from the module foo.py. So the essence is that you should mock an object where it is used and not where it came from. All right. So with that, I'll talk a little bit about when you should use mocks. So mocks are essential when you're doing a lot of system calls. Okay, so maybe you're checking the environment variables, or maybe you're checking the date time. I mean, any system calls that happen, right? Any operating system calls. So I'll take an example from a library called JovianPy, which is the backbone of the Jovian data science platform. So where I interned for a few months and I worked on their unit testing library, where I worked on their unit testing. So there's a library, there's a function called get conda bin, which basically gets the some path variable. Okay, so to test this, you just write I want to patch the dictionary called os.environ, and then give it this dictionary. So and then I call get conda bin and I check that it is getting the right path, which I have only provided here itself. Right? So system calls, right? So system calls is when you should use mocks. Next is network or API calls. So you wouldn't want your every time you run your unit testing suite, you wouldn't want your production or staging API to get bombarded with these API calls. So that would probably cause some throttling issues. So so if you have a get current user function, so I mean there's a get current user function, sorry, and it has it does a get request. Okay, and the test for it is a little it's a little what do you call, long, but I'll let me bring it, let me make it a little big. So now if you see here, let's break it down step by line. So in the first line you have the mock.patch, and it's used as a decorator here. And what is it mocking? It's mocking requests.get. Okay, so because if you saw in the previous slide, so if you saw in the previous slide over here, I'm calling the get method. I mean the get function, right? So that's why and which is actually imported from request library. I should have showed that, but you can trust me on this. So I mock requests.get and I pass it a side effect. Side effect, basically, I'll talk about side effect now. Okay, and so what is side effect? So side effect is when I call requests.get, what should happen, right? What should happen, and that I can give it a function which will dictate what happens. So when I pass in the parameters to get, it will simply pass it over to mock requests get. So it will say, it'll like say, okay, you take these parameters or arguments, and then you give me what I should output. So that's what happens, right? And a little about side effect. So if you see here, I create a mock object with the side effect as a key error. So when I call that object, it gives me a key error. So this is how I can play around with side effect. So when side effect is a function which returns some value for a particular key based on some dictionary. If I call mock on some key A, it will return 1. If I mock call on some key B, it will return 2, and so on. And if it's an iterable and like a list containing 3 strings, first this, then this, finally this, and if I call them one by one, it will return the items in those lists. So this is very nice where maybe you have some function that gives you different return values in the same test in the same function. So how would you test that? You would test that using side effect and passing a and assigning the side effect to a list. So this is from the docs of this side effect. So let's get back to when we should use mocks. So system calls, network or API calls, IO operations, and unpredictable results. So because you need tests to be deterministic because each time it cannot change. Okay. So now I'll talk about using context managers. Okay. So it's a simple protocol that your object needs to follow so it can be used with a with statement. Okay, you need to add 2 methods. One is called dunder exit and other one is called dunder enter and dunder exit. So I'll show you an example. So if you see this dunder enter method, it's just printing entering the context, and the other one is printing exiting the context. So now when you instantiate this class and use it with the with statement with foo and print hello world, it will first execute the enter method, then it will execute the block of statement in the with statement, and then it will execute the exit method. So entering the context, hello world, and exiting the context. And context lib is a library that the people at the Python, the folks over at Python Software Foundation have made a long back. So they gave a library called context lib, and you can import a class called context manager, which can be easily used to create these context to create these ordering of execution of statements. So here I'm going to speak a lot of jargon, which is this is a context manager passed as a decorator to a generator. This foo is actually a generator because it has a yield statement. So I don't want to get ahead of myself by saying too many things here, but basically you can think of it as it will just print whatever is before the yield, and then it will do after it when it yields, it will print all the things in the with statement, in the with block, I mean. And then after it yields from the with block, it will print the remaining statements. So it's like an enter is before the yield, exit is after the yield. Okay, so now that we have this, so with that context managed, so that's a pun that I tried to do. So now we can now move on to the next part. Okay, so context managers in unit tests, right? You can create a context manager called temporary directory or temp directory, which basically gets this it creates a temporary directory, and it changes into it, change directory into it. So whatever you want to do in that directory, you can do. You can create file, you can delete a file, you can create directories, whatever you want, whatever testing the function, whatever you can test a function that does all these file system operations. And another one is called mock git repo. This is another that's there in our in the Jovian test library. I mean, in the Jovian library. So this so Jovian uses some git operations in some of their functions. So how do you test those? You need to create a mock git repository where you test those functions. And I just all right. So now I'll talk about pytest. So there are 2 features in pytest that I want to cover today. One is called fixtures, and there are many fixtures. There are many built-in pytest fixtures. I'll talk about what fixtures are soon, but there are many built-in pytest fixtures like capsys, testdir, temp path, tempdir. All right, and you can create your own custom pytest fixtures. Okay, so at this point I'm comfortable to explain what a fixture is. So a fixture basically, it creates an instance, right, of your SMTP connection, let's say in this case, and you can use that instance everywhere in all your remaining tests. So that in each test you don't have to create that instance again and again. So fixture, it allows you to create like shared resources. Okay, and this is one of the tests that are this is one of the, sorry, fixtures that are present in the Jovian library, where it creates an instance of something called CLI runner, and I scope it to module so that it's same across the module, right? So and that instance can be used everywhere. There's another feature called parameterize, which I can pass a list of test cases and it will run against the same test. Okay, so I can say test eval, assert eval, test input equal to expected. So I don't need to write 3 assert statements for all these 3 inputs. I can just pass it a list and it will loop through those inputs and create 3 tests out of it. Okay, and if you look at this, this is another test that are there, that's there in the Jovian library. So it tests that 2 URLs should be joined properly. So there are multiple test cases, and it tests all of these one by one. So with that, I come to the end of the talk. I covered a lot of features about. I've covered a few features about PyTest. I've covered mocking. Um, I've also covered the difference between unit test and PyTest and why PyTest seems like a better option. Um, and yeah, that's the end of my talk. And I have some memes to drive home some of the points that I've covered today. So I mean, this is a popular meme that you should write tests. Sorry, like people generally back off from writing tests. When they write their code. So I mean, please always test your code. Um, so one does not simply code without unit tests. Okay, so that's another meme template. And this is very interesting. Okay, so fix your code to pass unit tests, or do you fix your unit tests to pass your code? Okay, so it's like you should rather fix your code to pass your unit tests. Okay, so never fix your unit tests to pass your code, because that means you're modifying reality and you're fitting it to your own code. Then there's no point in unit testing if you fix your unit tests to pass your code. All right, that's pretty much it. So here are the references for the talk, and thank you.